Welcome to my course on PLC programming, and this is the third video in which I will be explaining the PLC hardware in the context of S7-300 PLC. So let's get started. Well, this is the outline of my today's lecture, and I will be discussing the personal computer, the analogy with the personal computer of the PLC, and the PLC hardware components, and finally I will configure the PLC S7-300 PLC in the software, the programming and configuration software, that is Semantic Manager. So let's make an analogy with a personal computer. In a typical personal computer, we have some input devices like a keyboard and like a mouse. All these devices, input devices, send data to the CPU and memory. We have output devices like a printer, like a monitor, and these devices output or shows the data from the CPU, like in the case of monitor, and the output data in case of printer is displayed on a document, right? So these are the output devices. We have some input devices, and the CPU has the processing capability to process the data coming from input devices such as mouse, keyboard, and microphone, process the data according to the program stored in the memory of the PLC. So the data and program both are stored in the memory while the CPU processes the data according to the program. And the power supply unit is also installed in this CPU cabinet, which supplies power to all these devices like CPU, memory, and keyboard, some input devices, etc. So this is pretty simple and you may be familiar with it. So I will try to draw an analogy between a personal computer, where I discussed in this case, and a PLC. The PLC has the same functionality, except the fact that PLC is customized for industrial applications. This is why we call it a PLC as an industrial computer as well, because it is customized with the rugged environment of an industry. So these are the PLC hardware components. We have some input modules that take devices from that takes data from some input devices. We have some output modules that is interfaced with some devices like motors, valves, and actuators. We have a power supply that converts the AC in most of the PLCs to DC voltage because the modules are operable on DC voltage. We have a CPU which processes data stored in the memory according to the program. And we have a communication interface because we have to network the PLC and we have to interface some devices with serial cables, etc. So these are the main hardware components of a PLC. Let me explain it one by one, each of the PLC hardware component. The very first is input module. The input module interface devices like switches, like proxy sensors. For example, we have a 24-volt switch that I have interfaced just to make you guys understand. Well, whenever I press the switch, the circuit is closed and the 24-volt signal will flow to the input channel of this digital input. Similarly, devices that send digital data to the PLC, in this case, I used a digital module for explanation purpose only. We have analog input modules as well that takes the analog data in the form of 420 milliampere as an input to the PLC input module. So this is SM321 input module of 7300 PLC, SM321. And over here you can see that DI32 cross 24 volt, DC 24 volt has been written on the module. It means that this module or this card has 32 channels, and each channel takes 24-volt digital signal as an input. The 24-volt digital signal, as I showed you in this case, may come from sensors that have been being installed in the field. There may be some switches, there may be some proxy sensor, uh, speed monitor, etc. So the input module takes care of the signals coming from various sensors, switches, etc. Next up is the output module. The output module, once the data is processed by the CPU, it will give commands to some devices that are interfaced with the digital output modules like valve, head of valve, like a motor, well, like an actuator. Okay, so whenever PLC gives command at certain channel, 24-volt will be sourced from this digital output card first channel, and we can feed the 24-volt any circuit that is energized, and that ultimately any valve, any motor, any actuator, or for example an indicator, bulb, etc., would be switched on. So this is how a number of devices can be interfaced with output module of a PLC. As you can see, we have DO16 cross DC 24 volt being written on the digital output module. It means that we have 16 channels, 16 different devices can be interfaced with this card, and each card has the 24-volt configuration. That is, the if this card specific channel, the first channel, has high signal, it means 24-volt is emerging or sourced at this channel, and the subsequent circuit or device is turned or switched on, right? So in this case, I just for explanation, I used a digital output module, but we also have analog output module that sends the data in the form of 4 to 20 milliampere DC current, right? So those devices which are compatible with the analog's output signal of 4 to 20 milliampere, those devices would be interfaced with the analog output module of the PLC. So next up is the power supply. Its job is pretty simple. It takes the AC voltage as an input and converts the AC voltage, as in our case it is 220 volt AC. It converts it DC voltage, 24 volt. And the purpose of stepping down it to DC 24 volt means the devices such as input, output modules of the PLC are being operated on 24 volt. And these 24 volt are fed into the modules through the backplane bus, right? If you look at the power supply, there PS307 and 2 ampere has been written. PS307 is the model number of this power supply, and 2 ampere it has the capability to handle the ampere, maximum ampere, and then 2 ampere it is its current handling capacity. And 24 volt is the output voltage of this power supply. Then feed the 24 volt L plus and 0 volt as an M. We can terminate cables that are then going to the CPU, because we have to energize the CPU as well. The CPU and memory. Well, the CPU, just like the personal computer, it processes data, while the memory holds the data and program, right? So the memory section will hold the data and the program, while the CPU will process the data according to the program stored in the memory. So as you can see, well, this socket, this holds the memory card, right? The S7-300 PLC memory card. Well, it may have 64 KB space or 120 kb, and it can go up to 512 kb as in typical cases. So this is a socket for holding the memory card, and this entire module is CPU 3152 dB as it is written over here. Well, this is the model number of the Simatic S7-300 PLC that I'm using in this example. There are certain indicators, LED indicators on the CPU module which shows the status, whether the PLC is in the run mode, it is in the stop mode, or it has any error. Well, there is a toggle switch. We can switch the status of the PLC from run to stop mode, and we can also have memory reset through this toggle switch. So this is the CPU and memory of the 7300 PLC. We also have some communication interfaces. In this case, we have some built-in communication interface in the CPU module, and this is for the serial communication. We can use it for Profibus, which uses 400 RS485 communication protocol. We can also use Modbus, MPI. All these are some communication protocols, and this port ensures that PLC is getting connected in a network. So this is the communication interface of the Siemens S7-300 PLC. In the last, I will show you how to configure the Simatic S7-300 PLC with all these modules in the Simatic Manager. So let's go to the Simatic Manager. I will create a new file, a new project, S7-300 Hardware. Insert a new object, Simatic S7-300 Station. Click on the hardware. A hardware configuration window will open. Come to the catalog. Over here, first we will bring a rake to the editor, and then first I will insert a PS307 2 ampere in the very first section. Then I will go for the CPU 3152 DP. Depending upon the specific type of PLC you are using, I'm just dragging the first one. Now I do not want to network it, but if you want a network connection, such as in this case, it is asking for a Profibus connection. Well, I'm not using any Profibus connection. I'm not using this PLC in any loop, in any Profibus loop. So I'll just cancel it. So this is the 7300 PLC CPU 3152 DP. And now I will insert a digital input card. A digital input card. SM321, 32 channels, each 24 volt, and a digital output card, SM322. It has 32 channels, each 24 volt. So I will save it, and I will compile it. So this is how I have added all these modules that I explained to you one by one in my presentation to the hardware configuration of my project. So that's all for now. See you in the next video.